In the previous module, we have made a migration from the Arrovian social welfare setting to the social choice setting. So where instead of looking at the social ordering, we are just focusing on one outcome, the social choice function f, that now maps the orderings, the preference profile of all the individuals into one alternative. And we have also defined several properties which are desirable in that setting, including that of strategy-proofness. And we have also introduced the notion called monotonicity. Remember what was monotonicity? It says that if you consider a particular preference profile, let's say P, and if the social choice outcome, that is the outcome of this function f, becomes A there, and if we consider another preference profile P prime where A's relative position has only become better, so the whatever was below A in the earlier preference profile P, that continues to be below A even in the new preference profile P prime, then this monotonicity property says that the social choice outcome at that new profile must also be equal to A. So this is what we say monotonicity. In some sense, the position of A is monotonically increasing or non-decreasing in the new profile context. You should continue to have the same the same outcome to be the outcome of the social choice function. Now here we have stated a theorem which says that this notion of strategy-proofness and monotonicity are one and the same. So we are going to discuss the proof of this theorem, and this will give us the flexibility of using monotonicity and strategy-proofness interchangeably. The purpose of giving the proof is to look at the proof technique, because the same proof technique will be using at various other conditions. It will be useful for general mechanism design proofs as well. So let us first prove the forward direction, that is, if a social choice function is strategy proof, then it must be monotone. First, let us look at the if condition of the monotonicity property. So the if condition, recall the definition of monotonicity, the formal definition. You have two preference profiles, P and P prime, and in the first preference profile, the social choice outcome is A. And relation between the dominated set of A, that is all the alternatives that are below A in Pi, will continue to be below A in Pi prime, and this should hold for all players I in N. So this is the if condition. Now we'll have to show using the property of strategy-proofness then that the Fp prime should also be equal to A. Now how can we prove that? We will actually look at the two extremes. So this is the preference P, and on the right, extreme right, we have the preference P prime. And we'll make this transition one at a time. So look at from P0, let's say the first preference P is P superscript of 0. At every stage here, so from P0 to P1, only player 1's preference changes to P1 prime. And this is the same P1 prime of this preference profile P prime. So only player 1's preference has changed, everybody else's preference remained the same. In the second transition, only player 2's preference has changed to P2 prime. All other players' preferences remain the same. And similarly, after n such steps, we will finally have the preference profile P superscript n, which is nothing but the P prime. Now we are going to claim that if you apply f at every such preference profile, all these intermediate preference profile, the outcome should be the same A in all these cases. And if we show this, we are already done, because at the final outcome, the final preference profile P prime, the outcome is also A. We prove it via contradiction. So let us assume that there exists some k minus 1, some transition, let's say k minus 1 to k, where the outcome, the social choice outcome at this p k minus 1 is A, but at k it has changed to some b which is not A, right? and what we know among these two profiles. So let us just expand out the profile. This is pk minus 1. So this, if you recall, this is the pk minus 1. So the preference profile before this transition here. So here player K had this preference P of K, and only player K's preference has changed to pk prime in this transition. The other thing to notice is that because these p primes have a very specific structure, that the position of A from pk to pk prime only weakly increases, right? So either the position of A in this p prime can be the same as A, or it can get better off. What it means is that all the alternatives that are below A in this pk should continue to be below A in pk prime, right? Now we also notice, because of our assumption, the outcome in this preference profile is A, while the outcome here is B. Now based on where this A and B are positioned in these two preference profiles, there could be three cases. So the first case is maybe A was above B in this preference, so B was somewhere below here, and B continues to be below A in the new profile, right? So that could be one case. The other case could be that B was possibly above A and B continues to be above A. That is, there is no problem in it. So when A's relative position increases, either something above A can go below A, but there can't be any alternative which was below A in pk that goes above A. So that is not allowed. So therefore, that is the reason we can have only these three conditions, these three possibilities. So B was above A, B continues to be above A, that is a possibility. B is above A, but B goes below A in pk prime. The last thing, that is B is below A and B goes above B, is not possible because of the assumption of pk prime. Now we can see that in all these cases, in these three cases, it cannot be. So if the outcome in pk prime, so this if this happens to be true, then this social choice function is not strategy proof, because in the first case, voter K will misreport from pk prime to pk. Why? Because you see that here the outcome is B, right, which is less preferred by this player. So when you are talking about this particular preference profile, player K knows if he reveals his pk prime truthfully, he gets an outcome B which he prefers less. But if he reveals pk by unilaterally deviating from here to here, then the outcome will become A, which he prefers more than B. Therefore, voter K will definitely misreport. The converse happens when you have the second condition. Then the player K will misreport from pk to pk prime, because in pk the outcome is A, which player K prefers less than B. And if he misreports to pk prime, he knows that the outcome will be B, and that will be more preferred by this individual, by this player K. And if the last thing happens, you can check that then K will be misreporting. Its player K's best response to misreport in both these preference profiles. So under all these conditions, it is seen that it is a contradiction to the strategy proofness of the social choice function F. So what we have assumed is not correct. So of course there cannot be any such cases where the transition changes the outcome. Now let us focus on the reverse direction. That is, we will prove if F is monotone, then it must be strategy proof. The way we will prove it is by the negation of it. That is, if a social choice function is not strategy proof, then it will not be monotone either. So let us first assume that F is not strategy proof, and if we on top of that assume that F is monotone, then we will actually end up in a contradiction. So let us look at how this contradiction works. So not strategy proof If F is not strategy proof, that means that there exists some player which has two preferences pi and pi prime, and other players have some preference profile p minus I, such that at that preference pi, player I can misreport his preference to pi prime and get better off. So that is the notion of manipulability. So this is not strategy proof. So let us just denote this the social choice outcome at pi prime p minus I with b and pi p minus I with a, right? So just for a shorthand. So what we get is that b is more preferred than a in this preference pi for player I. Now we are going to construct a preference profile denoted by p double prime, where all the other players, so if you look at the players except player I, their preferences do not change. They are holding on to their p minus I. Now what is this pi double prime? So for pi double prime, you keep b on the topmost position and a in the very next position for this player I. Right? Now you can think of two different transitions. One transition is from this pi prime p minus I to pi double prime, and the other one is from pi to p minus I to pi double prime. So let us look at this first one. So pi p minus I to pi double prime p minus I. So clearly, because at preference profile, the outcome is a, that we know, and the a's relative position, and what we also know is that in pi, b was above a. So if I pull up, so let's say pi that had b somewhere, b was definitely above a, and we do not know what is the position for the other things. What happened in pi double prime is we have pulled b to the top and a to the second top, right? So whatever was below a will continue to be below a, because that's the best thing that a can have, and therefore this condition holds that the dominated set of this alternative a under pi is a subset of the dominated set of a in the preference pi double prime. Now you also know that f of pi p minus I is actually equal to a. So therefore, using the monotonicity property, we can have that in this new profile pi double prime p minus I, the outcome should also be a. Now I apply a very similar argument for pi prime for the transition from pi prime to pi double prime. So now we are looking at the outcome, the alternative b, because that is the social choice outcome at this preference profile. Now there is nothing to worry here, because in pi double prime, b is on the topmost position. So no matter wherever b is positioned in pi prime, the alternatives that were below b will continue to be below b in this new profile pi double prime. Now using monotonicity, we can see that this outcome will be equal to b, the social choice outcome at the same preference profile pi double prime p minus I, that should be b, and this is a contradiction. By this assumption that this is not strategy proof, we can actually end up in a situation where it is not monotone either, because if it is monotone, then we end up in this kind of a contradiction. So that essentially proves the reverse direction as well. Now we have a small lemma here, which says that if you have a social choice function which is monotone or strategy proof, whichever way you want to call it, and onto, then it must be Pareto efficient. So remember that we have proved that Pareto efficiency is the most strict requirement. So Pareto efficiency implies that it is unanimous, the social choice function is unanimous, and if that is unanimous, it implies that it is onto. Now we start with the weakest condition, that it is monotone and onto, then it must be Pareto efficient, the stricter one. So the picture, it will look like something like this. So you have this Pareto efficient social choice functions are living here. They are contained within this unanimous social choice functions, and then you have this the onto social choice function, which is the largest set. Now whenever we are applying monotonicity or strategy proofness along with ontoness, the whole space will shrink to only PE. So what we can say is on the space of social choice functions which are strategy proof or monotone, these notions of Pareto efficiency, unanimity, and ontoness are one and the same. So let us now prove this lemma formally. So suppose, so this proof is again by contradiction. Suppose that the social choice function f is monotone and onto but not Pareto efficient. So what does that not Pareto efficient mean? That there exists a pair of alternatives A and B and a preference profile P such that B is above A for all the players, and the social choice outcome is choosing that Pareto dominated outcome A, Pareto dominated alternative A. Right, so it does not necessarily have to be B to be just above A. The relative position of B and A are something like this. B is above A, and this is true for all the players. So this is A is Pareto dominated, and that is coming out to be the outcome. Now the ontoness will also, so f is also onto, that is given. What does that mean? That there exists some preference profile P prime such that the social choice outcome gives you B, right? These are the two things that we are going to assume, so which we get by this assumption that it is not P. Now the proof technique that we will be using is very similar to what we did in the previous lemma. So we will construct a P prime, P double prime, right? So and what is the structure of that P double prime? The first position for all the players will be B. So this looks something like this. The first position is taken by B and the second position is taken by A for all the players. You see that at Pi prime, so that is the outcome here. The outcome is B. The dominated set of B under Pi prime is a subset of the dominated set of B at Pi double prime. So B's position has weakly become better, right? So that is because in P double prime B has moved to the top, so therefore this implication is definitely going to hold. And now if we apply this property of monotonicity, you get the outcome here in this preference profile must be equal to B. Now you can apply the transition from P to P double prime. So what will happen? We know that B is above Pi for all the players in this preference profile P. So what we have done in P double prime is we have moved B to the top and A to the second top. And because of that fact, all the alternatives which are below A continues to be below A. So therefore this relation also holds, that the dominated set of A under Pi is a subset of the dominated set of A under Pi double prime. And now you apply monotonicity again, you get this outcome to be equal to B and to be equal to A, because at P the outcome was A. That was a Pareto, not Pareto efficient outcome. And that is going to be a contradiction. So therefore what we have assumed is not true. So if it is monotone and onto, it must be Pareto efficient. So we have the corollary here, which essentially states what we just told earlier. So whenever we are talking about social choice function that are strategy proof or monotone, then all these statements are equivalent. So strategy proof and Pareto efficient is equivalent of saying f is strategy proof and unanimous, and f is strategy proof and onto. Now, why is that corollary useful? Because we are going to state a very important result given by Gibbard and Satterthwaite in 73-75. So it says the statement is very much similar to the arrows impossibility result. It talks about strategy-proofness. So now we are actually interested in making sure that the agents reveal their preferences in some truthful manner. And if we on top of that like to ensure this property of ontoness, and if there are at least 3 alternatives, then these 2 properties can be satisfied if and only if F is a dictatorial social choice function. Of course, because of this corollary here, you can see that we can replace this statement from onto to unanimous or Pareto efficient. So in certain other kinds of texts in certain other books might get the statement written as F is unanimous and strategy proof if and only if it is dictatorial, but all those statements are equivalent in this setting.